I want to talk about two problems this week. The first one is glass beads, and the second one is GATTACA. Okay, so glass beads, what is the problem about? You have a string, let's say this is your string, and you want to consider all possible rotation. What is a rotation? It's take, for example, the leftmost character and put it at the end and shift everybody over by one to the left. So for example, I shift everybody one position to the left, and the one A that's dropped out, it's now here. And then I can do this again. A, B, C, A, B, and again. And there are two more rotations, so B, C, A, B, A, C, A, B, A, B. Okay, so if you have a string of n characters, you will have generally n different rotations. And the problem basically asks, give me the one that is lexicographically smallest. So here, in this problem, in this example, this one is the lexicographically smallest. Now, of course, you can always actually do it brute force, generate all of them, find the smallest one. If you do that, that's going to be quite pricey because it'll take you n steps, and for each one you're going to have to do some kind of string comparison, and string comparison can take up to n steps while comparing every single character, so that's n squared now. Okay, now what we're going to do is instead we're going to take advantage of the fact that we have something called suffix array that we can compute either in n log n time or even linear time, depending which version of the library you use. So what we're going to do is that we're going to take our original string and we're going to double it. Okay. Now this is a trick that is often used whenever we want to look at a linear sequence in a cycle, and by extending it like this, you can see that any rotation is simply a substring of this doubled up string of length n, right? So you take any substring of length n, that's one of the rotations that you can get. So now what we're going to do is we're going to ask, what is the lexicographically suffix, right? So if you look at all the suffixes, C, BC, ABC, AABC, etc., right? And of course, this is exactly what a suffix array does. The suffix array will tell you that AABC is the first suffix, and then the next one is probably this one, and so on. Now, if you find that the first suffix, this one, that is the lexicographically suffixed, and you might say, well, okay, this is the correct answer, but the problem is you need 6 characters to get the full rotation, and you don't have that. So when you go through the suffix array, you will look through the entries in alphabetical order. That's how it's sorted. But you also have to look and see if there are enough characters. And because this one only has 4 characters, this is not what you want. So you skip that and you look for the next entry. The next entry is this suffix. And of course, it does have more than 6, at least 6 characters. So that's it. That's the answer. But of course, you have to take only the first 6 characters, right? So you do the suffix array, but after you double up the string, you look through your suffix arrays for the first entry that indicates a suffix of length at least n. Pick the first n characters of the suffix, and that's your answer. So that's glass beads. The other one is GATTACA. Oh, let me change the color of the pen. And I don't actually remember how to spell it, but that's kind of what it is. And you're asked basically a string of 2 strings of length up to 1000, SMT, the length is up to 1000, and you ask, oh, sorry, there's only one string, and you ask what is the longest repetition, longest substring that is repeated at least twice, and choose the one that's lexicographically small. Okay, so if you just run the suffix array after the original string, okay, then basically you will have all the suffixes that look similar appearing in the same order, right, and close together. And remember that we have something called the LCP array. The LCP array, if the entry, let's say this entry is 5, doesn't really matter, 1, 2, 0, 5, whatever it is. This 5 is going to tell you that the suffix before you and this suffix, the first 5 characters are the same. And that indicates that there's a substring of length 5 that repeats somewhere. Okay? So what do? If you want to look for the longest substring that repeats, you basically scan this LCP array and look for the maximum. Now, it does have a tiebreaker that says if you have multiple maximum, choose the one that is lexicographically first. So it's also very simple. If 5 is the maximum, you have a lot of 5, pick the first one, right? This is a suffix array sorted lexicographically already. So the first one that works is the answer. Now, because this is also just 1000, you can also, if you really want to, use some kind of dynamic programming. But in this case, there's no reason to do that, especially because you probably already have the suffix array code from the previous problem.